Namaskar. Last time we have observed and discussed what is the gradient of a scalar function, divergence of a vector function, and curl of the vector function. To understand the physical significance of these three terms, that is the gradient, divergence, and curl, there was a homework for you that if g is the scalar function, that is equal to y square. For simplicity to understand, a bar is a vector function, that is y j cap plus z k cap, and b bar is the vector function with minus z j cap plus y k cap. Then to understand the significance of these three quantities, first of all we will have to plot them on the Cartesian coordinate system. Now these vector functions and scalar functions are just for the understanding. These are simple vector functions and scalar functions to understand what is the nature of that scalar or vector function, and then how that nature can be expressed or can be elaborated with help of the gradient, divergence, and curl. We shall begin with the plotting of our first scalar function. That means we have given the scalar function g to be equal to y square. Now for simplicity, as x-axis is perpendicular to plane of figure, we had considered the function in yz plane. All the three functions are only in yz plane, because it is not possible to represent the complicated function which depends on all the three variables on paper, correct? You will have to imagine the three-dimensional situation and then it is possible. But for simplicity, to understand the meaning of these three quantities, we can proceed further with these simple functions. Now as we will have to represent the function in yz plane, I can think about the minus z axis and minus y axis too, and I can ignore the x-axis because it is perpendicular to the plane of figure and I cannot plot the function in three dimension. Now in previous video we have observed what is the meaning of plotting of a scalar function in Cartesian coordinate system. For that particular point we will have to write the values of that function g as a function of x, y, z, that is equal to y square in this case. Therefore at 0, 0, 0, this is the point, the value of g is equal to 0. At 0, 1, 0, the value is 1. At 0, 2, 0, the value is 4. At 0, 3, 0, the value is 9, and so on. Now I can think about the different points in yz plane, few points in yz plane. Just to realize, I cannot change the value of x, and for any value of x, these values are same. Therefore, suppose this is the x-axis which is perpendicular to plane of figure moving towards you. Then at this point, this particular point, that is x is equal to 1, say for example, y is equal to 1 and z is equal to 0, the value will be when? 1. That means above this point, everywhere the functional value is 1. Above this point, everywhere the functional value is 2, and also below this, because for positive x-axis as well as negative x-axis. But for this particular point, this point is 0, 1, 1, the value is also 1 because y is equal to 1. For this point, that is 0, 1, 2, z is 2, the value is 1. For 0, 0, 1, the value is 0. For 0, 0, 2, the value is 0. For 0, for x is equal to 0, y is equal to 2, z is equal to 1, the value is 4. That means here is the value 4. And now you can check for these points, the values are something like this. If I move towards negative side, it is y is equal to minus 1. Then you will observe that the value is equal to 1 here. For this point, the value is 1. For this point, the value is 1. For y is equal to minus 2, somewhere here the value is 4. Somewhere here the value is 4. Now here the value is 1. Here the value is 4. Here the value is 9. For this point is 0, minus 1, minus 1. That is value is 1. For 0, minus 2, minus 1. The value is 1. Here the value is 1. This point is minus z is equal to minus 2, say for example. Here the here the value is 4. Here the value is 4. Here the value is 1. Here it is 4. Here it is 1. Here it is 4. Here it is 9. Now you will realize that on xz plane, everywhere the value is 0. Xz plane, that is perpendicular to plane of figure. And to the right side, the value goes on increasing. To the left side, value goes on increasing. That means along y-axis, the value increases. Along minus y-axis, the value increases. And the increase in the value is proportional to the present, twice the present value at that time, okay, at that particular point. For example, here the change is from 0 to 1, but here it is 1 to 4, here it is 4 to 5, that means here the change is of 1, here it is of 3, here it is of 5, then it will be of 7 on both sides. And how it is, here the average value, a y value is 0, 1, average value is 0.5, therefore twice. 1, 2, average value is 1.5, it is twice. 2, 3, the average value is 2.5, it is twice, and so on. That means the function g increases rapidly along y-axis. See, if I travel along this direction, the value changes from 0 to 1, then 1 to 4, that means increase is 3. From this to this, it is. But for that, I will have to move a larger distance, it is root of 2. But this is the direction, that means y is the direction along which the function changes rapidly. Correct? This function changes rapidly. Now, if you think about the different possible functions, say for example, y square plus z or y square minus z square, etc., then you can plot the function and you can see a particular direction along which the function changes rapidly. Okay. Therefore, the functional value, the plot says that the function g changes rapidly along positive y-axis and as well as negative y-axis. Correct? As well as negative y-axis. Now we will calculate the gradient of g. Okay. What is the meaning of gradient of g? It is del operated on g. Now actually we are aware about the operation of del on g, and therefore directly I can write it is 2y j cap. Correct? You can solve this as a homework. Already you have done, because the homework was to plot these values and to find gradient, divergence and curl, and just you will have to verify that whether our plotting of a function is right and our values are, and just now we will correlate them. Now what it indicates, here you will realize that the gradient of g is 2y and j cap. Now you see here it is, if the average value of y is 0.5, then it is 1. Change is with rate of 1 per unit change in y. Here it is change in 3 per unit change in y. That means y changes from 1 to 2, but the functional value changes from 1 to 4. Here the y changes from 2 to 3 by 1. The functional value changes from 4 to 9, that is by 5, that is 2 times 2.5. Therefore, this 2y gives us the rate at which there is change in g, and this j cap will give us the direction along which that change is rapid, that change is fast. Correct? Therefore, the function changes at the rate of 2y along j axis rapidly, and therefore this will be the vector quantity which gives us the magnitude and direction along which the function changes rapidly. Now this is the significance of gradient of the function. Now as a homework you can think about, now see, if I give you the function something like this, it is 3x square y minus 2xy z, or okay, any function, then I know that for this, if I think about the gradient of a function, that is grad f, then I can think about it is 6xy minus 2yz, it is I cap, okay, it is I cap, plus 3x square minus 2xz, it is j cap, plus I can think about it is minus 2xy, it is k cap. But now this direction itself is a complicated direction. What is the component along y-axis? That is x-axis, y-axis, that depends on the present value or the values of a particular point, and it is complicated. Therefore, it is difficult to imagine. Okay, it is difficult to imagine, and therefore we had considered a very simple function, that is g is equal to y square, and we can elaborate this. Okay, therefore now the meaning is clear. But again, for simplicity, I can give you one more function. Suppose h is a function. I can say that it is, say for example, okay, this x-axis is there, it is perpendicular, therefore it is not suitable to take the x variation. But I can think about it is, say for example, y square plus z. Okay, if this is the function, then you will have to plot the values. Correct? Now try to by yourself. For example, if the value is, here it is 0, 1, 0, then the value is 1 because z is equal to 0. But here the value will change, here the value will change. And if you plot so many values, then you will get a particular direction along which that variation is rapid. That means you can think about, you may take some distance, say for example from origin at a distance 10 centimeter, what is the average value along 10 centimeter along this, what is the change along this direction, what is the change along this direction for a 10 centimeter on a graph paper. Okay, and then you will realize that along a particular direction that change is rapid, and that direction and the rate of change of that function will be given by the gradient of this function h. Now try this as a homework, and then you may realize what is the significance of the gradient. In the next video we will go for the significance of the divergence, and sequentially we will go for the significance of the curl. Thank you.